at notebook page 32, practice problems with density. So the first practice problem, the I do, it just simply asks determine, so there's my word determine, the density of the sample if 76.95 grams occupies 15.63 centimeters cubed. So here's the thing, is that we have to understand units. So if I see a number tagged cm cubed, I need to recognize it as a volume. Whereas I have another number that is tagged to the right with a G, and this represents grams, so I understand that I have a mass. And density, when I think about units, okay, a common density unit is grams per milliliter, which tells me the math, that I have grams over milliliters or grams divided by milliliters. So density is simply the ratio of the mass divided by the volume. So the 76.95 grams divided by 15.6 centimeters cubed. And when I put this into the calculator, I get all these digits. 4.9326326,923. Now I have to think through the process. Okay, a lot of digits on the calculator. Am I allowed to keep them? Well, the 76.95, it's a mass value. Do we have a piece of equipment in the lab that measures it? Yes. So the mass, this is a measurement. So therefore it has sig figs. This mass specifically contains 4 sig figs. Volume. Is this volume derived from equipment used in the lab to make measurements? Yes. So it represents measurements that have been made. Therefore, it contains sig figs, and the measurement, the volume has 3 sig figs. And because it's either multiplication or division that is occurring, then I have to round my calculator answer to the lower number of sig figs. So my calculator, I'm only allowed to keep 3. So I'm going to underline the 4, the 9, and the 3. The 2 does not make the 3 round up. So my sig fig answer would be 4.93. Now I also have to have a unit here. I have grams divided by centimeters cubed. The grams do not, there's nothing there to reduce the gram to 1, so it's still present. And the same thing for the centimeters cubed. There's not another centimeters cubed to reduce it. So both of them need to be shown in the final answer as grams per centimeters cubed. So now take a look at the next I do. So in this one, it asks what mass. So that means I need an answer that's going to end in grams. So what mass of gold occupies, and I see a number 100.0 milliliters, which is a volume. So in this problem, I have to change a volume into a mass. The relationship between mass and volume, it is the density. So my relationship to change between these two is the density. So that means I need a density value, and it's not, one is not given here. But I noticed that I am working with a sample of gold. So if a needed piece of information is not given to you in the problem, that means that you need to go find it in your reference tables. And if you take a look, you will find the density listed on table S. And you can find the density. So when you go to your table S, the density of gold is written as 19.3 grams per centimeters cubed. So now we have enough information that we can start this process. So I'm going to start my math with the value I'm given. So I have 100.0 milliliters. Now, when I take a look at the density value, I don't see milliliters in that density value. But I know that there is a relationship between milliliters and centimeters. So I can go from milliliters to centimeters cubed, and I want to be able to reduce those out. This is that relationship that you need to memorize. So 1 milliliter equals 1 centimeters cubed. So now when I do my unit analysis, milliliters times centimeters cubed divided by milliliters, the milliliters reduce to 1, so I'm allowed to cross them off. But now when I take a look here, so right now I'm in centimeters cubed, and I actually see that unit in the density value. So now I can easily go from centimeters cubed to grams and be able to reduce out the centimeters cubed. Now listen to how we say this. It's 19.3 grams per centimeters cubed. The 19.3, the unit I say immediately after I say that number is grams. So that means the 19.3 goes next to the grams unit in the relationship. So 19.3 grams. So I write down 19.3 grams per centimeters cubed. That means 1 centimeters cubed. And when I do my unit analysis, I have centimeters cubed times grams divided by centimeters cubed. The centimeters cubed I'm allowed to cross off because they reduce to 1. So now I have a calculator answer, and it shows up on my calculator as 1,930. So I have to figure out what should my final answer look like. So in the lab, this volume, it is measured. So therefore, it has sig figs. And so all my zeros are trailing. They all come to the right of the 1, but there's a decimal point, so it has 4 sig figs. This information here was looked up in a reference table. If you go and you look up the density value for gold in another chemistry textbook, it might have digits all the way out to the 10,000th place. So a relationship like density, we say that it has an infinite number of digits. So it has an infinite number of digits. So 4 sig figs versus an infinite number of digits, we round to the lower number of sig figs. It's 4 sig figs. The thing is the way that the calculator gives it to us like this, there's only 3 sig figs. We need that 0 to be significant. So in order for it to be significant, we have to write it with the decimal point to show that that 0 is a significant 0. And unit-wise, when we did our unit analysis, the last unit standing is grams, so we do need to tag that number with a G. Last example here. Move this up a little bit. I don't know. Now I just made a big mess. Let's get this eraser here. Oh, now it wants to move. Okay, so let's get the eraser so I can get some of this. Okay, here we go. Okay, last problem here that I'll go through. So it says, how much space? Now, space is just another way of saying volume. So how much volume does 3.67 Gs? So I see a number tagged with a G. So this represents mass of helium. So how much space does 3.67 grams of helium occupy at this temperature? So in this problem, I need to go from mass to volume. And in this case, okay, to change from a substance's mass to its volume, our relationship to get there is the density. So we're going to work through this problem much the same way we did the previous problem. So in order to solve this, so let me get it set up, we have 3.67 grams of helium, and we need to get to a volume. Well, volume, we have a variety of units that volume can be expressed in. So volume, we could measure it or express it in milliliters, centimeters cubed, liters, gallons would be the first few that pop up into my mind. So we need to get to one of those units. We also need to know the density value of our substance, which happens to be helium. So you need to go into your chemistry tables, and the density of helium, according to our chemistry table, is 0.000164, and that unit is grams per centimeters cubed. So take a look. The density fractional unit has centimeters cubed in it, so that's what I'm going to strive for since it doesn't tell me anything else in the problem. So I'm going to go from grams to centimeters cubed, and I want to be able to reduce out the grams. So when I read this, the density value is 0.000164 grams per centimeters cubed. So that 0.000164, it goes wherever I put the grams in the fraction. So if grams is in the denominator, that number goes in the denominator next to the grams. And it's 0.000164 grams per centimeters cubed. So wherever I put centimeters, it's that per 1 centimeters cubed. So when I look at the units, grams times centimeters cubed divided by grams, gram upstairs, grams downstairs, they reduce to 1, cross them off. Here's the unit I'm left with, which is a legit unit for the amount of space or volume occupied. When I put this into the calculator, I get a pretty big number. It's 2,2,3,7,8, I think like 0.08 was something like that on the calculator. So I have to think through the process of, do I get to keep all these digits? Do I need more digits? Well, mass, this is a measurement that you make in the lab. So this is a legit measurement. So it has sig figs, and it has 3. The density of helium, it's a relationship. So just like the one for gold, it has an infinite number of digits. So you go and you look at another reference, it could be several more digits beyond the 4. So we can only keep 3 sig figs. Here they are, the 223, but the 7 makes the 3 round up. So my sig figs are 224, but 224 is a very different value than 22,378. So that means I need to add a couple of trailing zeros to get the value to be maintained. So 22,400 is a very similar value to 22,378. But the 4 is the most right sig fig, so you cannot add a decimal point at the end of this number, because then it would change the sig figs from 3 to 5. So another way that you could write this value would be in scientific notation. 2.24 times 10, and then I would need to move the decimal 4 places, so my exponent would be a 4. So 2.24 milliliters, or 22,400 milliliters. Now, you have 2 you-dos to do at the bottom of this page. Let's see if I can get these to show up. And these are both 2 steps. So you have a step A and a step B in both of these. So step A, you need to use the information that is given, and you need to show your correct numerical setup of how you determine the volume based on the data that is provided. Part B, you need to show your work as a dimensional analysis of changing that volume into mass using your density relationship. So you're going to see a very similar thing in the second you do. Show your correct numerical setup to determine the volume of the sample. And then, just like the other one, dimensional analysis to show your work of converting the volume into the mass. Show your final calculated work to your teacher.